And now let's solve a numerical example of the marginal utility for a typical Cobb-Douglas utility function. So now suppose that our alpha is 0.3 and 1 minus alpha will become 0.7. So now we will have our utility function u, or function of x and y, is equal to x to the power of 0.3, y to the power of 0.7. So now find out the marginal utility of x and the marginal utility of y. Then the marginal utility of x is equal to the partial derivative of utility with respect to x, and is equal to 0.3 multiplied by x to the power of 0.3 minus 1, y to the power of 0.7. And now we will have our marginal utility of x is equal to 0.3 multiplied to x to the power of 0.3 minus 1 will become 0.7 multiplied by y to the power of 0.7. And we can write down as a 0.3 multiplied by x over y to the power of 0.7 with negative sign, or we can write down more simplified it, marginal utility of x is equal to 0.3 multiplied by y over x, but now to the power of 0.7, because when we move, so the sign will change. So now the marginal utility of x for this typical utility, Cobb-Douglas utility function is equal to 0.3 multiplied by y divided by x to the power of 0.7. This is the marginal utility of x. And one thing that you may know here, the marginal utility of x, it depends on how much y and x unit of consumption we already have. How much unit of y and x consumption or consumption bundle we already have. So the marginal utility is going to change. So it means the marginal utility in case of Cobb-Douglas utility function is not fixed. It depends on how much y and x unit of consumption we already have. So now, so this is the marginal utility of x. So now let's find out the marginal utility of y. The marginal utility of y. Then the marginal utility of y, is equal to the partial derivative of utility function with respect to y this time. So now we can write down 0.7 multiplied by x to the power of 0.3 multiplied by y to the power of 0.7 minus 1. So then the marginal utility of y is equal to 0.7 multiplied by x to the power of 0.3 multiplied by y to the power of minus 0.3. And then we can write down marginal utility of y is equal to 0.7 multiplied by x over y to the power of 0.3. Because when we shift y to the denominator, so then the sign of the power of y will change to the positive. So then the marginal utility of y is equal to 0.7, which is the power of y here, multiplied by the ratio of x over y to the power of 0.3. Again, the marginal utility, as we had for the x as well, the marginal utility of y, it depends on how much x and y consumption we already have. So then the marginal utility of y and x in case of Cobb-Douglas utility function is not fixed. It depends on how much x and y we have in our consumption. Thank you so much, and let's work on another types of utility function in the next video. See you.